For years, the competition between Tesla and BYD has been measured by familiar numbers: electric vehicle sales, battery technology, manufacturing efficiency, and global market share. Most observers assume the next chapter of that rivalry will follow the same path, with each company introducing better vehicles, reducing production costs, and expanding into new markets. But that assumption may already be becoming outdated. Instead of focusing solely on electric cars, BYD is now investing in something that seems far removed from the traditional auto business. The company plans to introduce humanoid robots into its dealerships, where they could welcome customers, explain vehicle features, and assist throughout the buying process. On the surface, it sounds like an attention-grabbing demonstration. In reality, it may represent the first step in a much broader industrial strategy. The larger question is not whether robots can help sell cars. It is whether the technologies that built today's leading electric vehicle companies can also power tomorrow's robotics industry. Batteries, electric motors, artificial intelligence, sensors, and advanced manufacturing all play critical roles in both fields. BYD's decision to introduce humanoid robots into its dealerships may seem unconventional, but from an operational perspective, it is a logical place to begin. Unlike public streets or private homes, a showroom offers a structured environment where nearly every variable can be controlled. The layout rarely changes, customer traffic follows predictable patterns, and employees are always nearby if assistance is needed. For a company developing advanced robotics, this creates an ideal testing ground. Rather than attempting to build a machine capable of handling every possible situation from day one, BYD appears to be focusing on a smaller set of repeatable responsibilities. A humanoid robot can greet visitors, provide basic information about different vehicle models, explain charging options, guide customers toward specific displays, and answer frequently asked questions. These are tasks that rely on consistent interactions rather than complex decision-making, making them well-suited for early commercial deployment. The dealership also serves another important purpose beyond customer service. Every interaction becomes valuable feedback for engineers. They can monitor how accurately the robot understands questions, how people respond to automated assistance, and where software improvements are still needed. Small issues that might not appear during laboratory testing become visible after hundreds of daily conversations with real customers. Importantly, BYD has not suggested that robots will replace human sales professionals. Purchasing a vehicle remains a highly personal decision involving trust, negotiation, and individual preferences that machines are not yet equipped to handle. Instead, the robots are expected to support dealership staff by managing routine explanations and repetitive inquiries, allowing employees to spend more time helping customers make informed purchasing decisions. This gradual rollout reflects a broader development strategy. Instead of promising a fully capable household robot immediately, BYD is choosing an environment where success can be measured. Software can improve continuously, and practical experience can be gathered before expanding into factories, commercial facilities, and eventually everyday living spaces. At first glance, electric vehicles and humanoid robots appear to belong to completely different industries. One transports people from place to place, while the other is designed to perform physical tasks. But beneath their very different appearances lies a surprising amount of shared technology. That overlap helps explain why companies like BYD and Tesla believe they are well positioned to compete in robotics. Both products rely on many of the same core systems. Electric motors generate movement, rechargeable batteries provide energy, power, electronics manage electrical flow, and sophisticated software coordinates every operation. Cameras, sensors, processors, and artificial intelligence allow both vehicles and robots to interpret their surroundings and respond to changing conditions. Although the final products serve different purposes, much of the engineering expertise required to build them is remarkably similar. Manufacturing experience may be an even greater advantage. Designing an impressive prototype is one challenge. Producing thousands of reliable machines at competitive prices is another. Large automakers already understand complex supply chains, quality control, automated assembly, logistics, and cost optimization. These capabilities are difficult to replicate and often take decades to develop. BYD enters this market with an additional strength because of its vertically integrated business model. Unlike many manufacturers that rely heavily on outside suppliers, BYD produces a large portion of its critical components internally. Its experience spans battery technology, electric drive systems, semiconductors, power electronics, and advanced manufacturing equipment. Every improvement made in one business can potentially benefit another, creating efficiencies that specialized robotics startups may struggle to match. This is one reason the robotics industry is attracting established vehicle manufacturers rather than only software companies. While artificial intelligence remains essential, commercial success also depends on building durable hardware that can be produced consistently, serviced efficiently, and sold at prices businesses are willing to pay. Those are areas where experienced industrial manufacturers already possess significant expertise. As robotics moves from research laboratories into commercial environments, production scale could become just as important as technological innovation. The companies capable of combining advanced AI with efficient manufacturing may ultimately gain the strongest competitive position. That is precisely the combination both BYD and Tesla are attempting to build, making robotics a natural extension of capabilities they have spent years developing through the electric vehicle industry. While customer-facing robots may attract the most public attention, BYD's larger objective extends well beyond its dealerships. The company is also exploring how humanoid robots could transform its manufacturing operations, where the potential economic impact may be even greater. If successful, these machines could become another layer of automation inside factories that are already among the most advanced in the automotive industry. Today's vehicle plants rely heavily on industrial robots, but most are designed for a single purpose. One robot may weld body panels, another may apply paint, while others repeatedly install the same components thousands of times each day. These systems are exceptionally efficient, yet they are also highly specialized. Changing production often requires expensive reprogramming or even new equipment. Humanoid robots offer a different approach. Because they are built to operate in spaces originally designed for people, they can theoretically move between workstations, handle different tools, transport components, inspect finished products, and perform a wider variety of assignments without requiring an entirely new factory layout. Instead of replacing every existing robot, they could fill the gaps where flexibility is more valuable than specialization. This vision aligns with BYD's interest in highly automated manufacturing facilities, sometimes referred to as dark factories. The term does not imply that factories will become completely human-free. Engineers, maintenance teams, quality inspectors, and supervisors will continue to play essential roles. Rather, it describes production environments where routine manufacturing processes become so heavily automated that certain sections can operate for long periods with minimal human intervention. In such facilities, humanoid robots would work alongside robotic arms, autonomous transport vehicles, machine vision systems, and AI-powered production software. Together, these technologies could create manufacturing lines capable of operating with greater consistency, fewer interruptions, and faster adaptation to changing production requirements. For BYD, this is not simply about reducing labor costs. Greater automation can improve production efficiency, shorten manufacturing cycles, enhance quality control, and allow factories to respond more quickly to shifts in consumer demand. As electric vehicles become increasingly competitive and profit margins tighten, these operational advantages could prove just as important as developing the next generation of batteries or vehicle designs. Viewed from that perspective, humanoid robots become more than an experimental technology. They represent another tool for improving industrial productivity, reinforcing the idea that the future of manufacturing may depend as much on intelligent automation as it does on the products rolling off the assembly line. Long before most automakers began discussing humanoid robots, Tesla had already positioned robotics as a central part of its long-term vision. Elon Musk has repeatedly argued that Tesla should be viewed not simply as an electric vehicle manufacturer, but as a company focused on artificial intelligence and intelligent machines. In that strategy, vehicles are only one application of a much broader technology platform. The centerpiece of that vision is Optimus, Tesla's humanoid robot. Rather than designing a machine for a single industrial task, Tesla aims to build a general-purpose robot capable of performing a wide range of physical work. The company's long-term objective extends beyond factories, envisioning robots that could eventually assist in warehouses, businesses, and even residential settings. Tesla believes its experience in electric vehicles provides a strong foundation for this ambition. The company already develops high-performance battery systems, electric motors, onboard computers, cameras, and AI software for autonomous driving. Many of these technologies can be adapted for robotics, allowing Tesla to build on years of engineering investment instead of starting from scratch. One important advantage is Tesla's ability to test its robots within its own manufacturing operations. Factories provide structured environments where engineers can observe how machines perform during real production activities, while continuously refining both hardware and software. This approach allows problems to be identified and corrected before robots are introduced to outside customers. Even so, building a commercially useful humanoid robot remains far more challenging than producing an impressive demonstration. Walking across a stage or completing a carefully rehearsed sequence is very different from working productively throughout an entire shift. A practical robot must recognize changing environments, manipulate objects of different shapes and sizes, recover from unexpected situations, and operate safely around people without constant supervision. Perhaps the greatest engineering challenge lies in human-like dexterity. Hands perform thousands of delicate movements every day that most people rarely notice. Grasping fragile objects, using tools, pressing buttons, opening containers, and adjusting grip strength all require remarkable precision. Replicating that level of control consistently and reliably remains one of the most difficult problems in modern robotics. Tesla has earned significant public attention through Optimus and has invested years into its development, but maintaining that lead will become increasingly difficult as more competitors enter the field. Companies like BYD are no longer watching from the sidelines. Instead, they're applying their own manufacturing expertise and AI capabilities to pursue many of the same opportunities, setting the stage for a much broader competition in industrial robotics. While much of the public discussion focuses on the rivalry between BYD and Tesla, the broader competitive picture extends far beyond two companies. One of China's greatest advantages in humanoid robotics is the industrial ecosystem developing around the technology. Instead of relying on a single manufacturer to drive innovation, China has built an extensive network of companies specializing in batteries, electric motors, sensors, precision gearboxes, semiconductors, machine vision, industrial automation, and artificial intelligence. Together, these businesses form a supply chain that can accelerate development across the entire industry. This ecosystem did not emerge specifically for robotics. Much of it evolved alongside China's rapid expansion in electric vehicles over the past decade. As manufacturers invested heavily in battery production, electric drivetrains, advanced electronics, and automated factories, they also created many of the capabilities that humanoid robots require. Now those same suppliers can support an entirely new category of intelligent machines without having to build a manufacturing base from the ground up. Several Chinese companies are already demonstrating how quickly this market is evolving. Firms such as Unitree and UBTech have introduced increasingly capable humanoid platforms, conducting factory trials, public demonstrations, and commercial pilot programs. At the same time, electric vehicle manufacturer XPeng has announced plans to expand production of its own humanoid robot, viewing robotics as a natural extension of its broader artificial intelligence strategy. This growing competition creates an important advantage for the industry as a whole. When multiple companies pursue similar technologies simultaneously, they collectively drive improvements in component quality, manufacturing efficiency, and production costs. Suppliers receive larger orders, research progresses more rapidly, and successful innovations spread throughout the market far faster than they would if only one company were developing the technology. Another important factor is manufacturing experience. Chinese companies have repeatedly demonstrated their ability to scale emerging technologies once commercial demand begins to grow. The electric vehicle industry provides a clear example. Over a relatively short period, manufacturers expanded production, strengthened domestic supply chains, lowered costs, and became major global competitors. Many industry analysts believe a similar pattern could eventually emerge in robotics if commercial adoption accelerates. This does not guarantee that any individual company will dominate the market. Competition inside China is becoming increasingly intense, with manufacturers racing to improve software, hardware, and production efficiency at the same time. But collectively, this ecosystem creates an environment where innovation can move quickly, giving companies like BYD access to specialized suppliers, experienced manufacturing partners, and a domestic market large enough to support rapid testing and continuous improvement. As a result, Tesla is no longer competing against a single rival. It is increasingly competing against an entire industrial network that is investing heavily in the future of intelligent machines. If that ecosystem continues to mature, it could become one of the defining forces shaping the global robotics industry over the coming decade. Despite the growing investment and ambitious announcements, humanoid robotics remains an industry in its early stages. Recent demonstrations have shown impressive progress, but commercial success will ultimately depend on solving a series of engineering challenges that are far more demanding than they may appear during carefully controlled presentations. One of the most significant limitations is energy efficiency. A humanoid robot performs thousands of continuous movements while powering cameras, sensors, processors, and artificial intelligence systems simultaneously. That places enormous demands on its battery. Improving operating time without making the robot excessively heavy remains a difficult balance for engineers. Mechanical reliability is another major concern. Every joint, actuator, and gearbox experiences wear as the robot moves throughout the day. In a factory or commercial setting, these machines may be expected to work for many hours with minimal downtime. Even small mechanical failures can interrupt production, increase maintenance costs, and reduce the economic value of the entire system. Software presents an equally complex challenge. Humans constantly adapt to unexpected situations without conscious effort. A misplaced tool, an unfamiliar object, or someone suddenly stepping into a workspace rarely causes a person to stop working. Robots, however, must interpret these changes through cameras and sensors before deciding how to respond safely. Unexpected conditions can still confuse even the most advanced artificial intelligence systems, limiting their effectiveness outside controlled environments. Perhaps the greatest obstacle is human-level dexterity. Tasks that seem simple, Opening a package, connecting a cable, picking up a fragile object, or adjusting grip pressure require extraordinary precision. Human hands combine strength, flexibility, and sensitive touch in ways that engineers are still working to replicate. Building robotic hands that can perform these actions repeatedly without damaging objects or wearing out remains one of the industry's toughest technical goals. Safety also becomes increasingly important as robots begin operating alongside people. A humanoid machine is both powerful and mobile, meaning it must constantly monitor its surroundings, avoid collisions, and react appropriately when conditions change unexpectedly. Achieving that level of reliability is essential before businesses can confidently deploy robots on a large scale. There's also a broader design question facing the industry. A humanoid robot may be well suited for environments built around human workers, but it is not automatically the most efficient solution for every task. Warehouses, for example, may benefit more from autonomous wheeled vehicles, while repetitive manufacturing processes often remain better served by fixed robotic arms. To justify their higher complexity and cost, humanoid robots must demonstrate that their flexibility provides measurable advantages over more specialized automation. These challenges do not suggest that the technology lacks potential. Rather, they illustrate why the path to widespread adoption is likely to be gradual. The companies that succeed will not simply build robots capable of impressive demonstrations. They will build machines that perform consistently, safely, and economically in the real world day after day. As impressive as humanoid robots may appear, the companies leading this industry will not be determined by the quality of promotional demonstrations alone. Businesses make investment decisions based on measurable financial returns, and that means economics will ultimately become the deciding factor. A robot must do more than function. It must create enough value to justify its cost. For any company considering robotic automation, several questions come first. How much does the machine cost to purchase? How expensive is routine maintenance? How much electricity does it consume? How often does it require repairs? Most importantly, can it perform useful work consistently enough to improve productivity over time? These practical considerations often matter far more than whether a robot looks human or performs impressive movements on stage. Reliability is especially important. A robot that completes its tasks successfully only part of the time may appear promising during a short demonstration, but even occasional failures can become costly in a commercial setting. In a manufacturing facility, one unexpected shutdown can disrupt multiple production processes, delaying output and increasing operating expenses. Businesses need equipment they can depend on every day, not just technology that performs well under ideal conditions. This is where manufacturing scale becomes a major competitive advantage. Producing robots in large volumes allows companies to reduce component costs, improve production efficiency, negotiate better supplier agreements, and spread research and development expenses across thousands of units. These cost reductions can make advanced robotics affordable for a much broader range of customers. Both BYD and Tesla understand this principle because it has shaped their success in electric vehicles. Over the years, they have refined manufacturing processes, simplified production, strengthened supply chains, and continuously lowered costs through higher volumes. Those same strategies can be applied to humanoid robots, giving both companies an advantage over smaller competitors with limited manufacturing capacity. Each company also brings different strengths to the market. Tesla benefits from its reputation in artificial intelligence, software development, and years of public investment in robotics research. BYD, meanwhile, can leverage extensive vertical integration, large-scale manufacturing, and access to China's highly competitive supplier network, which may allow it to reduce production costs more rapidly as demand grows. In the end, the winner may not be the company with the most sophisticated or human-like robot. It is more likely to be the company that delivers dependable performance at a price businesses can justify. If humanoid robots become a standard tool across factories, warehouses, retail stores, and service industries, affordability and operational efficiency will matter far more than headline-grabbing demonstrations. As history has shown in the electric vehicle market, technological leadership is important, but commercial success ultimately belongs to those who can scale production and make advanced technology economically practical.